want to take a look at how the transformer works, right? So watch this. Do I trust this for a while? I just know it's good, yeah. Like either China. Okay. All right. So what's here online? If you look here, there's a nice. Like either China. Okay. Right. Online, you'll see that. Online, you'll see it, right? Right. Thanks, Annalise. Right. So, Annalise, right? What we have here is a basic transformer, right? What you'll have outside, what you'll have outside, like on the lines and thing. This is a simplified version of it. What you would recognize here is that the transformer has a few things. You see that silver ring? That silver ring is called a soft iron core. It's the same material that they make it's the same material that they kind of make magnets from. It's a soft iron core, and around the soft iron core, we have wire, and we have the wire wound around it, like two big solenoids. You see that? And there are two sides there, a primary side and a secondary side. Everybody see that? Right. Transformers don't really be one-to-one because they're kind of useless. What a transformer is used for is used to take a big voltage and give you a small voltage, or take a small voltage and give you a larger voltage. Like for example, on the wires outside, the voltage that comes into our home is much larger than the value we actually use it. For example, like here, right? These little plugs, they use like 110 volts. Like here, I don't have any here, like ACs, they use 220. So the largest voltage that we did in our homes are 220. But the wires, they don't transmit 220. They transmit much larger values. So we can't take those values into our homes. We have to find a way to make it smaller. And this transformer does it, right? And watch how it will do it, right? The switches reach. What do you should think, buddy? Hold on, eh? Why must be when I get up? You have a thing that change. Okay. No, but I didn't. Anyway, if you look here, now there are more coils on the right hand side. You see that? I have a few more coils on the right hand side, less coils on the left hand side. So if you look closely, you might see it because some of the kind of far. This voltage, smaller than this voltage. This voltage is slightly larger, right? It's gonna get a little bigger. Anyway, so basically by changing the number of coils, I can make the voltage bigger or larger, right? Bigger or smaller. Hold on, eh? I'm gonna change this simulation. Let's see if PHP or mobile good. Or not. Right, I like it. That's not, give him one more try, okay? One more try. Where is it? Much time he needs to. Where is physics class? Right? That's just everything. I just think too long. I will just have to explain. Oh no, all right, so here's how it will work. So basically, this is how it looks. You have this soap iron core. I will draw mine in a rectangular version, right? And you just have coils here, just as I showed you, and you have coils here. Let's put some more coils, right? This is the primary side. This is the secondary side, right? And our supply is alternating, right? And we will receive our alternating output as well, right? Here we have number of coils in primary. Here we have number of coils in secondary. Right? And here we have number of coils in secondary. All right. So what you have to look at is the number of coils and see which one is larger. If the number of coils in the primary, if the number of coils here is more than the number of coils here, what that will do is that will step down your value. So that will give you a big value, turn it into a small value. So when the number of coils in the primary is more than the number of coils in the secondary, what we have is a step down transformer because the voltage will go from a big to a small. That's okay? So for example, outside, we have a step down transformer. It takes the large voltage being supplied and steps it down to supply us with something smaller. Okay? And the main thing that does that is just the number of coils. All right? And then if the number of coils in the secondary is more than the number of coils in the primary, what we have is a step up transformer. That's okay? The step up transformer. Right? Nice. So how do we now check out these values now? So if I have a voltage here and a voltage here, what you would recognize is that there's a nice ratio that always happens. If you divide the number of coils in the primary by the number of coils in the secondary, that will always be equal to the voltage in the primary divided by the voltage in the secondary. This is a transformer relationship. That's okay? So by changing this, you will also change this. That's okay? Right? And here's how it actually works, right? So you imagine this. You all remember Faraday's law? Whenever conductor has a magnetic field, current is induced. You remember that from last week? So watch this here. If I have a alternating voltage flowing here, and if I have current flowing here, and there's also a magnetic field, yeah? So if there's a magnetic field around this coil, and it alternating means it always changing direction. And the magnetic field cut this off iron core. Hence, yeah. So remember the magnetic field going and keep changing direction. And just as we learned last week, that magnetic field cutting this core will cause current to flow in here. Okay? And if current flowing in here now, then this will become a big magnetic field. And that magnet now will transfer the magnetic properties here, right? And if you have more coils to receive it, you'll get bigger voltage. If you have less coils to receive it, you'll get smaller voltage. That's okay? So the magnetic field from here will transfer the magnetic properties here. And we learned again that if the magnetic field is present in a conductor, there will be a voltage. That's okay? So basically, we transfer the voltage from here to here by electromagnetic induction. That okay with that? Right? So you're transferring the magnetic properties from here straight to here. And by doing that, you're transferring a voltage from here to here. If you have more coils, you're going to get bigger voltage. If you have less coils, smaller voltage. Are you okay with that? Are you okay with that? Okay, make a note of this. I'm going to give you a little, I'll give you a small note afterwards. A short. A long note. You're going to get a long note. Okay. Anybody have is the breaking through in the open? I'm there, right? Ready? 1 minute, and then let's take this note. And look at it. Yeah, I'm ready. Ready? Finish. Just fix that. Hurry up. Should I have your phone? It's not going to down. Okay, they want it. Are you ready? All right, let's go. Let's go. A transformer works. Right. A transformer works. A transformer works through the principle of electromagnetic induction. Okay. Electromagnetic induction. One word, right? Electromagnetic induction. Yeah. Electromagnetic induction. First up, it is an electrical device used to, it is an electrical device used to It is an electrical device used to transfer electrical energy, used to transfer electrical energy between two or more circuits. Between two or more circuits. Full stop. its primary function is to change the voltage level from the primary supply to the secondary by either stepping the value up or down. What's up? How it works. Next subheading, how it works. Did that small notes, but take a little break again. Take a minute break. Rest your hands for a minute. Give me all these notes, take on as well, tag up, but for now, your turn. Well, huh? Just think about it, that's good. Because sometimes a question can say, explain how you transform a work charge. You gotta be able to explain it. So, right? Ready again? Give it a rest there, right? How it works. How the transformer actually works, right? Ready? When an AC voltage is applied, are you okay online? When an AC voltage is applied to the primary coils, current begins to flow through it. Current begins to flow through it. Current begins to flow through it. Full stop. Since current is alternating, since current is alternating, comma, it is constantly changing direction. It is constantly changing direction and hence generating a magnetic field. And hence generating a magnetic field. Full stop. This in turn creates a magnetic flux. This in turn creates a magnetic flux. What does flux mean again? FLUN. Close, a little more than that. Flux means what? Flux means the amount of field in a particular area. Okay? So flux means the amount of field in a particular area, right? This in turn creates a magnetic flux in the core. of the transformer. In the core of the transformer. Up. Okay there? Right, so we just explained how the magnetic field leaves the coil and then goes to the core, right? Put in brackets now. Faraday's law is applied, right? Otherwise, you forget that, right? Put in brackets. Faraday's law is applied. Put in brackets now. Faraday's law is applied. So now we go to the next stage. How it goes from the core to the secondary. Right, full stop. The magnetic field in the core. Yeah, continue. The magnetic field in the core. The magnetic field in the core passes through the secondary coil. And by Faraday's law, it induces an alternating voltage in the secondary coil. It induces a secondary something wrong there. Alternating voltage in the secondary coil. Sorry. And it induces alternating voltage in the secondary coil. And alternating voltage in the secondary coil, right? Right? So I explained to you how it went from here to here to here. That's okay? And the more coils we have here, the bigger this will be compared to this. Okay? So this is the ratio that we're looking at. That's okay, Naria? I want to add one more thing here, Naria. That's okay? Everybody okay so far? Yeah? If I call you now, you can explain how it works. Anybody? Okay. Okay. Why is that? Why is that? All right, nice. Last thing. So we know this ratio, right? We want to have an idea how current behaves as well. Because if it has a voltage, it also has a current, right? That's okay? Right? If it has a voltage, and it also has a current in coils. So we had to find a way to understand how current behaves as well. We learned that based on this ratio, we can figure out how voltage will behave. If I have more coils here, more coils to less coils, bigger, smaller. If I have less coils, more coils, smaller, bigger. But we still don't know how current behaves. All right? So here's what we're going to look at. We're going to look at the power transmission, right, between coils. All right? So I'm going to look at the power supplied here and the power supplied here. Okay? So if the transformer is ideal, what that means is what does ideal mean? What does ideal mean? Anybody? Huh? Like it? Going good with it. Perfect, right? So you do it good. You do it perfect, right? Right? You remember ideal gases? All right, let me pretend I don't remember, right? But an ideal transformer, what that means is that it is 100% efficient. Right? 100% efficient, as David said, is going good. Right? So it means that the power supplied, right? Power in the primary, that's the power being supplied. And because it's going good, it's giving it back that same power. So nothing being wasted. That's okay? Power in the primary equals to power in the secondary. Are you okay with that? So if it's going good, these two things equal. If it's not going good, these two things not equal. All right, but for now, we're focusing on ideal. All right, so how do we find power? Power is what? Anybody? Power is what? And again, pilots. Pilots in the calculator. Power is one chance here, then the whole clock. Power is what? Huh? Work done over time, that's correct, but not in this case. So you're close to the $5. You have $1 in the pie. Vital. Run your phone to security. Huh? Okay. Yeah. 1 week. No, the one next week. Okay, into the current. Power is what? It has something with voltage, yeah. Power is equal to I by V. Remember that? Put them in at your license. Okay. Right? So power is current by voltage, right? So how do I find power in the primary? Real simple. And the current in the primary by voltage in the primary. How do I find power in the secondary? Current in the secondary by voltage in the secondary. Are you okay with that? Right? So you have to know this formula, right? If I rearrange now, watch this nice thing here, right? Bring in this here. So I'll get VP divided by VS, and I bring in this here. IS over IP. Are you okay with that? Are you okay with that? So watch this here. VP on VS is what? VP on VS is NP on NS, right? So what does that mean? It means that NP on NS is equal to IS on IP, which is VP on VS. So it simply means this. When this value big, this value big, this value small. You're seeing that? So they kind of upside down. When the voltage high, current low. When the voltage low, current high. You're seeing that? Same thing from right here. When this value big and this value small, this big and this small. That's okay? But look at what happened here. And the secondary ended upside down. It upside down. It upside down, eh? So when this big, this small. See enough? When this small, this is big. That's okay, it's upside down. Are you okay with that? So it's behaving reverse. When the voltage in the primary is large, the current in the primary is small. Okay? In case you're not seeing it, because someone is watching it, it's looking like it's not making sense, right? Watch this here. 1/2 is the same as 3/6. Right? When this value big, when this value small, this value is large. Correct? When this value is small, this value is large. All right? So all I want to learn in short, after I write all of this here, all I want to learn is that current and voltage, they behave in reverse. So they're kind of inversely related in a way. Okay? Right? We're going to do some numbers now and I'll work on it, right? Might make a little more sense with the numbers, right? Again, so what I want you to understand is this relationship here. But will this work all the time, Charles? Would this relationship happen all the time? No. This only happens when it is 100% efficient. If it's 75, we had to change this whole thing. right? Now this here works. Okay. But most of our questions will be ideal, so we're going to focus on that first. All right, copy it down, and then let's put some numbers in it and make a little bit of sense out there, right? Right, so what I want you to gather from this whole thing is this relationship here. Okay, it's the most important thing. So take a colored ink and do something around pasta or anything you want. All right. Action. Let's put some numbers into this. You know that Mario, eh? But yan mo formula. You know that Mario. All right. So let's take a look at example one, right? And I will do example one here, right? Ready? All right, and so go ahead. Go ahead. So let me rush over. Let's say you go too fast, then wait. Right, so we're going to apply everything now, right? Those who finish, I'm excited to the question. Part A, what type of transformer it is? Right, so let's take a look at that transformer then. All right. Those who doing labs are gonna send a lab schedule next week, right? Who doing labs in here? I kind of push out the labs to you, so you don't get tired of just two labs, right? Right, we are on 18 to or 20. Somewhere in between them. How many people have lab books already? Okay, who do have lab books? When you have some, make sure I'm going by a lab book today for you. Show my hands again. Who need lab books? You have like 4 months, so the go and buy. I see 5 things. I see 5 months, right? You only have 4 more remaining. You need a lab book, right? So in your lab book, you don't have any writing to do besides log and calculation. A discussion when you ask ChatGPT for the answer, please be present, right? And everybody use it now. Okay? So when you ask ChatGPT, tell her spend 30 minutes in my class, using it as well. So until that you can answer, right? And Make sure when I ask you, you can react. All right, let's go. So problem number one. Problem number one is that I gave you a transformer there, and we need to know what type of transformer it is upside. That's out here. What type of transformer is this? I have 200 in primary, 1000 in secondary. What type of transformer is that? Up or down? Up, because the number of coils in the secondary is more than the number in primary. So therefore, it's a step up. You okay with that? Nice. Problem number two. This will go to your friend, Nuria. Nuria, I would like to find, right, I want to find the voltage in the secondary. What relationship you want to use to help find that? We have this, and we have this. Which one do you want to use? The one down at the end? Right? So you want to use NP on NS is equal to VP on PS. That's what you want to use? You want to use that? Yeah, well, she said yes, so yes, you are correct. So now you're going to put in the values. NP is how much? 200. NS is 1000. VP is what? 10. And VS is, we don't know, we're trying to find out, right? See how to work out this now. How you work out two fractions separated by equal sign? Cross multiply, right? VS by this. What if you want to get cross off zeros and thing if you want, yeah? Let me don't get too technical. Let me just cross multiply. This by this by this. Right? And then what to do? Tie across 200. So you'll get VS. VS is equal to 10,000 divided by 200. When I work it out, I got 50 volts. That makes sense? David, you agree with that value? Or it should be smaller? Let's see it. All right, before I do that, does 50 make sense? Does 50 make sense? Should it be a bigger value or smaller value than 10? Because it's a step up, right? All I did is that I put in the values. You okay with that? Then I cross multiply, did this by this by this. And then I carry across 200 and I get my answer. Alex? So whenever you see fraction, then all you're going to see for today class. Cross multiply, then solve. Okay? Copy it out. Any questions online? Huh? You ready for a break already? About 25 minutes, I'll get one. So, how long class have I get? You got this now.
Yeah.
Last part. Last part. If it's ideal, if the transformer is ideal, what does that mean again? It means it is 100% efficient. It's perfect, right? It's perfect. I would like you, if ideal, I would like you to find current in the prime. Think about it. And I'll rub it off. So you have it in your notes. What do I do? What relationship do I use? What relationship do I use? And I will pick one. Alex. I'm going to ask about the follow Alex. Right? At mouth now. What do I use? I want to find IP. tell me the relationship that I can use. I rub it off so you can't show me there, right? What do I do here? Online message answers, huh? Anyway, well, I can pull on there, right? I will start to take answers after this one. Yeah, I want to find IP. So I have to use a relationship with IP in it. NP over NS is equal to IS over IP. That's it, right? NP is 200, NS is 1000, IS is 2, IP are trying to find it. Before you work it out, should IP be bigger or smaller? Should the value here be bigger than this or smaller than this? Should IP be bigger than IS or smaller? Smaller? I must it be even in reverse. If IT is smaller than this, then I wanted to show you something, right? VS was 50. If you all see that IS is smaller than this, then it behaving the same way. Remember, I said current and voltage should behave in reverse, right? So if this voltage larger, then this current should be smaller than this. So this value here should be larger than 2. That's okay? Let's see. It should be larger than 2. Right. So cross multiply and do your thing. 200 IP is 2000. IP is 2000 divided by 200. And you'll get 10. Everything works out nicely. This current here is larger than this current here. Huh? We'll try the formula. Well, no, all are the same formula. You use voltage. Yeah, you'll get the same thing. If you choose VP on VS, it's IS on IP over. That's what I meant? Huh? Sure, go at this side. Find both the father and son. Hello, okay with this? Ghana? Sure. Any questions online? Let me see who here most likely not paying attention. Narayan, you okay? Celine? Sam. And go. See it up. Maybe they kind of but the current value on either side, right? What you did. So why I'm going to ask about the God order in here. Bini, oh yeah, Bini next door, Elena, and back there. Lindsay, you okay? Sit up. Sit up. That's the one I'm looking. She don't use time. See that you there? Okay, see that. Nice. Right, so I just changing it up a little bit. Do your little thing. Tell me what you get. You don't have to join diagram, just write the bars if you want, right? Same scenario where you find everything come up. Same scenario. Right? So I'll put here about 1500 for the 1500, here's about 500, right? This is 2 amperes. There's about how much? What are you feeling for? I feeling for. Right? I don't know these two fellas here. I want to know what type of transformer. What type of transformer? I want you to find VS somewhere. Right? I want you to find VS. And then here, I want you to find IS. Go ahead. Do your thing. I could take this off. Anybody writing here? Taking this off, right? Do your thing. ABC. Good. No hope? None? Some? So let's see. Number of secondary smaller than primary, so therefore it's a step down. Right? You have more here, less here. VS, NP is what? NP is 1500 over NS is 500. VP is 4 over VS. Right? Do your little thing, cross multiply, and then divide. You'll end up with 4 by 500 all over 1500, which is 4 over 3 volts. That's okay? I'm gonna do step by step because I feel somehow they didn't like the max thing there. Max. Yeah, that's correct. That's correct. 1.32.
Yes.
Right, yes, some order. 1.32 on the leg shaft calculators. Don't get the exact fraction. Right? 4 over 3. Investment Casio at much before the question is 1.33. Okay? And here, same principle. 1500 over 500 is equal to current in the secondary over current in the primary. Cross multiply, you'll get 500 IS is 3000. IS is 3000 over 500, which is. Okay with that? Right? Okay. Everybody okay? No? Come on. Come on. Go ahead. After that. Very good.
Somewhere.
Ready again? Right, let me get a little harder now. And 10 minutes, 15 minutes again. Hold on, huh? That's fine. Too long to love, be there now. It's a little bit hard. No? Anybody write it? Alex, you got you? Right, so it's 75% efficient this time. No longer 100%. We had to figure out what will happen, right? I'll help you with C, but if you can do it, go right ahead. Let's say here's 1000. Here is, I don't know. Here is 4 amperes. Here's 10 volts. Even and here is 40 volts. I want you to find in this order, find NS, find NS, after you find NS to me, find this, and then find, oh wait, no, just NS. Find NS to me, and then find IS. If you can't do IS, I'll help you. All right, IS a little tricky. Oh yeah, find NS to me, and then if you want to try it, go ahead. If not, I will help you. The last one, and then we are out. Last one, and I'll be. Take your time. Try to get NS first. You can do IS right there. Try to find NS first. Efficient. 75% efficient. What that means? Hey, I want to know. All right, so let me see what you got here now. So we're using NP on it as a cooler. Well, what's our ditch? That's a nice transition there. Right? So we had to work this out, right? So this is 1000 over NS is equal to VP, which is 10 over 40. Cross multiply, and you will get 10 NS is equal to 40,000. NS is equal to 4,000. That's okay? Right, that's the easy part. Now for the slightly tricky part, right? If it were perfectly ideal, if it was ideal, then the power input is always going to equal to 100% of the power output. That's okay? This is if ideal. Is it ideal? It's not ideal. So the power input is now equal to what? That's not. Let me just reword it so it will always work, right? Sorry. I switch it around so it will always work, right? Because you always go and get the same power input. So the power output is 100% of the input if ideal. But if 75% efficient, then the power output is how much? Is 75% of the power input. That's okay? So if it's ideal, this is what will happen. So how do we find power input? Power input is current in the, power output is current in the secondary by voltage in the secondary. That's okay? Ijaz, what are you doing? Right? By 75 over 100 by power input is what? Current in the primary by voltage in the primary. All you have to do now is to use this relationship and put in what you have. So put in your values that you have and then solve for IS. All right? Take a 2 minutes and try that. I'll show you that now. Okay? And then you want to find the IS. Michael, when you find the IS, that's not this. That's not. That Martin, quick, if you don't hear any of them, all right? Lindsay. Hi, Lindsay online. All right, today, Daniel. Elijah White. We're online. Serena was there. Cupid. Cupid, Jamie. Doreen from Isaac. Name. Salario. Leonardo. Gwyneth. John. Alex. Sabiva. Devana. Maria. Seda. Brianna. Manuel. Shedan. Chris. Dante. Paro online. Narayan online. Caleb. Caleb online. Oh, Caleb. Ethan, Rachel. Daniel. Daniel. Done. Plug in your values there, right, Solia? Plug in your values there, somewhere again. Teachers, Raj, Kathy, Jamari, Calista, Anya, Craig, Israel, Chelsea, Chelsea, Eden, Ashley, Robin, Brianna. Nice. If we didn't hear any other team, right? All right, last thing, are we done? IS, we're trying to find out. VS. Right, VS. And this is 0.75 by IP. IP is 4 and the VP is 10. Right? So you're getting IS is equal to 40 over 40 by 0.75. So you get 0.75 amperes. Yeah. So you vote out that way as well.
So.
Huh? I'll take that. Will it work all the time? Right? It wouldn't work if it's primary, right? If it's primary, you'll have to get it into one. All right, so nice. That's where we handle questions like this, right? Before you run away, homework, I just wanted to write down. The transformer has some problems, right? It's not perfect. Right? So I wanted to write down the problems with the transformer and how it's fixed. Right? 3 problems, 3 fixes. Yeah, 3 different ways to fix it. Okay? So I wanted to write down the problems with the transformer and how we fix it. Right, then we will practice some more of this. I'm doing magnetism circles.